Parallel lines, algebra, angles, we are doing. Section all about parallel lines and angle pairs. Angles to find, show lines parallel. AI, AE core, consecutive vertical angles mostly we are using. Okay, that would be so annoying to try to do that the whole time. So this section is all about using parallel lines and angle pairs to find angles or show lines of parallel. Mostly, we are using alternate interior, alternate exterior corresponding consecutive vertical angles, etc. to solve and find things. So, we are looking at this set of parallel lines. These two are parallel, that's why the little arrows are there. These two are parallel, that's why the arrows are there. This line down here is on its own. So really, the very first part of this section is all about finding all the angles that are on here. So you're looking to fill out every single spot on here with the proper thing. Honestly, you can do almost all of this without, almost just by looking at it and knowing some different basic things about angles. So this is 107. We should know that across is also 107 because those are vertical. Now, if you're talking about corresponding angles in the same spot on the same parallel line, same transversal on parallel lines, we know that corresponding angles are also congruent. So if this is 107, this one also has to be 107 because they're both on the top part of the x. And in fact, if we look this way, because we know that these two lines are also parallel, this is in the top, this in the top is also 107. And then we can just fill in vertical 107, 107. Hey look, this is on the top, this is on the top, 107, 107. So really, it's not too bad. All of these x's, crosses, whatever you want to call them, they're always in the same pattern, same order, same numbers. Now, this one, it's not 107 and 107 because this line is obviously not parallel to these ones. So then we got to find this part here. And this is why we practiced this last, on that first section we did. This is a straight line. It's a straight angle. Straight angles, as you hopefully remember, 180 degrees. So whenever you have a straight line that's cut by two, these are a linear pair. They add up to 180. So you can do 180 minus 107, and then I'll get you 73. And then magically, these are vertical, 73. This and this are alternate interior, because they're on the inside of those parallel lines, right? And they are on opposite sides, so they're also 73, which means this is 73. This and this are alternate interior. These are vertical, alternate interior, vertical. So it follows the same pattern. You're just basically filling in the info. All you've got to be able to do for the most part is know that they add up to 180 and the vertical angles are the same. So we're just going to do the same thing down here. If this is 51, this is vertical 51. This is alternate interior to this one here, so it's also 51 because they're on the inside of these lines on diagonal. These are vertical 51. So then we just got to find that last part, which these add up to 180. So 180 minus 51 gives you 129. These two are alternate exterior because they're on the outside of these two vertical line, parallel lines, and they're on opposite sides. So this is 129, this is 129, vertical 129, vertical 129. So that's basically what we're doing, is filling out angles, and then it'll get oh, whoa, how do I make this not so crooked looking? Crooked looking, crack-a-lackin'? Okay. So the change in the next part of this section is I'm going to add some algebra to it. So it would be something like I'd put an angle, something right here, and I'd have like 9a plus 3. All right, and then I could do something like on an angle here, I could put This is where b squared minus 4. 2/3 c plus 7. Right? So now I'm just adding some algebra to it. Your first step, I would say, is just to label all angles. And it's good practice anyway. So what I mean by that is what we do here, we're going to copy what we did up here. So 96, this is also 96, right? 96, 96, 96, 96, 96, 96, and then let's find out what this angle will be. If you did 180 minus 96, you get 84, 84, 84, 84, 84, 84, 84, 84. Yeah. Or you can say 84. 113, 113, 113, 113. Do some math and say 180 minus 113. I get 67, 67, 67, 67. And then the reason we do that now is now we have 9a plus 3. And we're just going to set it equal to whatever was there. 84. 9a equals 81 divided by 9 divided by 9. A equals to 9. And we're just going to do the same thing. So it's taking what we just did. I almost just flipped you off. And then adding algebra to it. So then we have b squared minus 4 equals to 96. Plus 4, plus 4, b squared equals 100. The opposite of squaring is square rooting. You get b equals to plus or minus 10. And then the last one, 2 over 3c plus 7 equals 67. Minus 7, minus 7. 2 over 3c equals 60. Got two options on how to do this. How I would normally do it is the opposite of 2/3, because we always do opposites. Opposite of plus 7 is minus 7. Opposite of squaring or square rooting. Opposite of adding and subtracting. Opposite of 2/3 is 3 over 2. Those cancel out, leaving you c equals. How do you do 60 times 3 over 2? Well, one of you would be like, oh, put it over 1. And then when you're multiplying fractions, you go straight across. 180 over 2. 180 divided by 2 is 90. Parallel, angle, pairs, and algebra. I was about to say boom, finished. But apparently I didn't actually have that down far enough for you to see what was going on. That's my alarm, 6:43. Yeah, the Xbox Series X goes on pre-sale in 17 minutes. Pre-order. See if I'll actually be able to get one or not. Who knows? So we had 2 over 3c plus 7 equals 67. Subtracted 7. Well, I said it all already. I guess now you can just see what I was doing. But yeah, to get rid of fractions, multiply by its reciprocal. And then you're good to go. Adios.